cool. I want to bring our previous project. Let me see. It is here. I want to load our previous project. So I'm actually, let me put this here. Actually, let me get rid of this. Let me make sure I have the right thing here open, to be honest. Just a second. I want to okay. Actually, yeah, I don't know, I might actually had something from here before, but we had the lab 5 before. So I'm gonna actually just make a copy of this called lab 6. This should be where we left from last time. So let's do this. We're gonna have to open server, but I already have it here. So I'm gonna load the page from lab 6. And this is our previous one. Let's see. Yeah, this is our previous project. So first thing is, let's rename this, honestly, to be now assignment 4. And this, we haven't been actually changing this, but let me change the title. Then here, assignment 4. This should do it, and here, assignment 4. So, okay, there you go. So last time we did cameras and textures. By the way, yeah, I think I have some camera code here that was not there before. I just realized that. And that's fine. So I think I can move forward here. Yeah, I can move forward, but I can't move backward. And I can look. So let's, what I want to do, actually, let me grab the camera code. I think it would be useful. Oh, that's fine. That's fine. Let's keep it like this. Okay, let's just move on and see. Maybe we can just implement some other stuff later. But yeah, that's it. We have a world here, and you can just visualize it like that. I did some kind of minor changes in this project. That's why it looks a little bit different. Okay, so let's talk about spheres. So what I want to do is I want to create a file here called sphere.js, and I want to build sphere here, and this is going to extend geometry. Let's load this file here, and we should be able to create create a sphere here. Let's see. think it works. Print this. I think it works. Yeah. No, wait. What happened? Oh, there's a problem. Okay, I must call super. Yeah, I have to call super here. Okay, star sphere. It has our matrices in there. Great. So now, as usual, when you make a geometry, you have to just specify a list of vertices. And this is the tricky part. How do we get to generate these vertices, right? Let me get my tablet here. I want to draw something. Wait, hold on. Where's that? Sorry about that. Let me try to draw something here on Zoom. I'll see if I can. Let's see if this works. Oh, this is cool. I can draw actually here. This is much better. So the idea that we want to do is we're going to draw. Oh, we're going to draw a sphere. Let me actually make this better. I want to draw. I'll try to do my best here. I want to draw a sphere from triangles. Okay. So we're gonna. I think that there's many ways of doing this, but I think the standard one is to think about this as as a globe. Right? In the globe, we have latitudes and longitudes. So for the longitudes, you have the center one here that is like a straight line, but that as you go across, they kind of start to get curved, right? Like this. And the same for the latitudes. You have the equator line here. And then you have the latitudes kind of this. Sorry. So yeah, this is pretty bad hand drawing, but you get the idea. We have the latitudes and longitudes. And what you want to do is kind of like break these spaces or the cells into triangles. Right? We want to actually generate these triangles, all these triangles. And this way we can see the sphere. And as probably can imagine, the triangles on the poles, they'll be smaller, and the triangles here around the equator line, they'll be kind of larger. Okay, this is kind of a characteristic of this algorithm. But I think this is the easiest way of thinking on how to generate a sphere. And I think it's useful if you think about this as a grid as well. So let's think about this as a grid, or kind of imagine like a flat world map. Right. Where you have your latitudes, or your longitudes. And here you have your latitudes. So you should think on the kind of on a flat surface. You're gonna do kind of do the same thing, but now like, sorry. Kind of like this, right? And I think it's easier to think this way because now we have here our latitudes. And here we have kind of the long. Yeah, it's actually the opposite, sorry. This is the rows, the columns are the longitudes, and the rows are the latitudes and the columns are the longitudes. So now what we're gonna do, I think we're gonna start this algorithm by iterating on these points here. You're gonna iterate on these points and then map these points to the sphere. Okay, and I'm gonna go over the math to do that, but pretty much you're gonna have to, there is already like, we're gonna probably look it up on Wikipedia. There is a formula to map from kind of a Cartesian kind of coordinate space to a kind of spherical coordinate space, okay? That's what you have to do. But pretty much you're gonna need kind of some sort of, let's start with this double loop that goes, iterates on latitudes and longitudes. And then let's move on, let's go from there then. Then we stop and maybe think about it. So, okay, let me see, how do I stop this? I'll keep the drawing there. So I wanna create a function here called generate the points, okay? So the idea being, I wanna generate these points here in sphere, like in the sphere coordinate space from these points. And here we're gonna have this double for loop that I mentioned. It's gonna be for I equals 0, I less than. That's interesting. Less than what? Let's define the size for this map. Kind of. Let's define here. Here we have 1, 2, 3, 4, 5, 6. But let's give us an argument here. The kind of the size of that flat map, or if the grid, if you will. So I'm gonna give here size. Then less than size. I plus plus. And then here we're gonna do for lat j equals to 0. J less than size as well. J plus plus. So now you're iterating on these points, okay? And what I wanna do essentially is kind of map I'm gonna call another function here, maybe like Cartesian to spherical or something like that. Maybe let's make it this smaller. Cart to like this. And this is gonna be a function here. You're gonna give kind of latitude and longitude here. Later you're gonna talk about it, but this is gonna be the idea. And we're gonna define this function cart to sphere, giving the latitude and the longitude here. And we're gonna return a point here. For now, let's just like return point in spherical coordinate space. Any questions so far? Okay. So yeah, we are doing actually the opposite, right? We are doing now we are doing this function here, and this is our cart to sphere. This is our, it's like, looks like a kid handwriting. Where is this? Close this. Okay, well, there is a problem here that if we note that I actually put here latitude and longitude, and I could, for example, define these, let's say equals to I, and this equals to, and this equals to J. But those are not actually latitudes and longitudes, they are just coordinate points, like 0, 1. What we want to do is we want to transform these numbers to actually latitudes and longitudes. And latitudes and longitudes are defined in angles. There's actually different ways of doing it, but we're gonna, sorry, too many things to keep track of. We're gonna define the longitudes from, let's say, minus 360 degrees to plus 360 degrees. And the latitudes you're going to do from minus 180 to 180. So you're also going to see this definition from minus, you also see this from 180 to 180, and also from 9, then this would be the half of that, minus 90 to 90, right? This is also common. I'm doing the first one because it's easier to implement in JavaScript, because once we have, I'm going to do the first one because we're gonna be easier to kind of calculate these angles using pi and the pi constant. But what I want to do is use I and J to map to these angles here. Let me stop this thing. Okay. So I want to define here latitude to be equals to math.pi times I divided by size. Okay, this is now how we map. So now what you're doing is pi here is 180, right, in radians. So we're gonna do these calculations in radians because the cosine function actually works in radians. So, but you can think of a pi to be a 180 degrees. So what I'm doing is I'm multiplying by the index, dividing by the size to normalize it. So this is actually computing the latitude here. And the longitude is very similar, but you're going to do 2 times pi times J divided by size. So this is doing this mapping here from, so 360 is 2 times pi, right? I'm dividing by the index. So I'm multiplying by the index and then dividing by the size to normalize it. So this is, in this case, if this is 0 and this is 0, 1, 2, 3, 4, 5, right? Because I'm normalizing it, if J is 5 and size is 5, then we get 2 pi, which is 360. If J is 0, we get 0 divided by size. And yeah, it's going from, as it is here, is going from, yeah, actually we should, yeah, yeah, it's a little bit different. So this, if this is 0, it's going from 0 to 360. That's fine. I think that's fine. Let's keep it this way and move on and see what happens. So, but this is how you compute the latitudes and longitudes. And okay, what I want to do is, so I want to now say lat maybe P, or maybe spherical point equals to this, and here I want to compute this spherical mapping. And I have here actually on Wikipedia, I found this. Oh, let me clear that. We can. I found here on Wikipedia the formulas we need, and we need exactly these three here. So this is how you map from spherical to Cartesian, or if it's vice versa, right? And actually what we are doing, oh, we are doing the opposite, by the way. I just realized. We are doing this. Right? We are getting the latitudes and longitudes already on the circle. That's why it goes from 0 to 360 and 0 to 180, as opposed to minus 300, minus 360 to 360. So we're actually doing the opposite. And here we want to compute x, y, and z, okay? Using these formulas. And r here is the radius of the circle. Theta is the latitude. And this phi here, or phi, sorry, phi is the longitude. So we can simply actually use those formulas. Our radius is going to be 1 by default, so you can disregard the r. But so this is going to be math.sine of latitude times math.cosine of longitude. This is going to be math.sine of latitude times math.sine of longitude, and the z is math.cosine of latitude, okay? So this is mapping actually from spherical to Cartesian. And I'm sorry I said the opposite before. All right, let's print this and see what happens. Let's see if you print this, you should get a bunch of points. Let's return here. We can return a vector 3, x, y, z. Or we don't need actually, we don't need any vector operations in here. So I'm just going to return an array. Okay. This is easier, I guess. Okay, let me see. Let's see what happens. We are not calling the function. So let's call generate points, passing size, and let's give a size in the main function. Let's say 20. We can think of like this size as kind of the resolution of the sphere, or the amount of triangles. So this is going to kind of be correlated with the amount of triangles, or proportional to the amount of the triangles in your sphere. Let's see. Okay, we got a bunch of stuff, like a bunch of numbers here that look like cosines and sines, right? They are all from -1 to 1. Yeah, this looks okay. There's no like not a number or anything like that. Yeah, this looks fine. It looks fine. Let's see. Remember, I think it's useful for later to actually generate the vertices, because now we have a bunch of points in Cartesian space. We have actually these points here, and I want to store them as a grid. I want to store them exactly like we drawn as a 2D array. So I want to see like this is going to be a new array of size, and then every time let's call this Cartesian points. And here, for every row, I also want to make the longitude, which is also an array size. Okay. And then I'm going to store this here at cart I j. So now we are storing this for each of these points here. We are storing their values. Any questions? Okay, cool. Yeah, just let me know. You can stop. Feel free to stop anytime. I know that kind of this is a little bit tricky. There's a lot of math in here and trig, but it's pretty much like the I think the takeaway is that we are mapping from this to this. Okay, so now we are just storing this grid. We have this grid here stored in this variable. I can return that grid here. Okay, so now we can actually get it here. Let's call this, let's get it outside here. Maybe like Cartesian points. And then finally, now I want to make a generate vertices function that take this Cartesian points and generate the triangle vertices, or all the triangle vertices. And we're going to call this here. Oh, these, remember, have to set the vertices, right? These dot vertices equals to these dot generate vertices. And we pass the Cartesian points here. And here we should return some vertices. Okay, so now the challenge is how do we like from these points, how do we make triangles, right? So what I want to do is, for example, pick this point here, or this. Oh, let me. For example, for this point, I want to make a triangle like this. I want to take this point, and this point, right? And then make a triangle. I also want to make a triangle from this point, and this point. And I want to do this for every point. So for every point, I want to pick the one below and the one to the right to make the first triangle. Then in the same point, I want to pick the below, the opposite, and the one to the right and make the second triangle. So for each point, we're going to make two triangles. Okay, make these two triangles to fill the entire sphere. So you're gonna have this for loop again for each of these points. We're gonna then find these vertices and make the triangles. Okay, so we're gonna need a for loop similar to this one. I'm gonna copy from here. But now we don't need all these things. And I'm gonna pass the points, just the size as well. We don't need this, but just to make it easier for now. Something that I think is gonna be useful is, let's do this from less or equal. And I'm doing this because, as you can see here, from this point, I'm gonna have to access the kind of the points after it, or like after it on the longitude dimension and after it on the latitude dimension. So I think I'm gonna make it go to less and equal here, and here I'm gonna make just go to less. So this is gonna make sure that we can always access the one after, the point after it. Or I mean, by after, I mean after, below, or after to the right. So actually, so first of all, let's print the Cartesian points here. See if everything looks fine. Yeah, we get a bunch of arrays. That's good. Yeah. So we have, this is our grid. And every point has a X, Y, and Z value, which is going to be used to generate these triangles. So essentially what I want to do is, I want to start, let's start, for example, with the first point here. Let's pick this point. This point is, let's call this guys just points to make it shorter. So points, for example, ij is the current point that I'm processing. So I go one, so this is this point, right? So this is the current point. I mentioned that I also need the one below, which is j plus 1. And I want the one to the right, which is I plus 1. So this is our first triangle. We also, and then we have our second triangle, which is this point, which is I, the one below, ij plus 1. I want this point, which is I plus 1, j plus 1. And I want the one to the right to make the second triangle. And this is the one to the right, which is this. Do you agree with this? Okay. Yeah, so this algorithm is a little bit tricky, but yeah, you're picking these points here, and then you're gonna move when I goes to 1. This is for I. If I equals 0, we're gonna pick these points. If I equals 1, we're gonna pick these points, and then if I equals 2, you're gonna pick these points, and so on and so forth. So, okay, so essentially now we're gonna have to kind of just concatenate all these vertices in one like big list of vertices. and return the vertices here. This is an array, right? All these guys are already arrays. So we can do something like this. Concat this, and then we concatenate those 3 points. We can do the same for all of them. This here, this here. And then this one here, this one here, and this one here. And I think, let's see, I think that's it. The only detail that is missing is that, remember that we specify our vertices to have also RGB and UV, right? So you're gonna have to actually put some default standard values here for now. Maybe what we can do is, I haven't done this before, but we can do this here now. We pass a color here, and then give a color to the generate vertices function. Let's call this points, just to make it shorter. Points, size, and color. Point, size, and color. And let's concatenate for each vertex. We need to concatenate also the color. So this is, yeah, I know it's gonna get a little bit like big, but you're gonna have to concatenate the color in here. And color is also an array, RGB. And we also need the UVs. So I'm gonna make a UV by hand here for now. Let's say all zeros. We're not gonna use a texture on this sphere for now, so I'm gonna just make default values. And I think that's it. Yeah, you could actually have, if you want to have less lines, maybe have everything here. I think this works as well. I think this works. Yeah, this maybe looks kind of better because we have everything in one line. Well, I don't know. Actually, I'm not sure if this works. I don't remember if I can put more than one argument. We can try later. Let's try like this first, and then see if it works. Let's try like this first, and then let's see if it works. So return the vertices, return the, oh, okay, let's make this also a new float32 array, because we need to make sure they are like that. And then that's it. We have our vertices. Let's try, see what happens. Oh, wait, we are printing this here, yes, but we're not drawing this sphere. Let's draw this sphere and give a color. Maybe here we give a color red. Okay. And then we draw this sphere. And for now, let's actually comment out our world. Just draw this sphere. Oh, sphere is not defined. Did I make it global? Ah, no. Oh, there you go. Yeah, I can't move the camera Okay, let me grab the camera. I have the code for the camera here somewhere. Yeah, I think this guy. Yeah, this guy has the code for the camera. Should be the same. Let's actually. I actually posted this code exactly as it is as part of that Minecraft demo. So this is the camera code. And then we're gonna have the controls as well. So let me just copy the controls so we can navigate in this world easily. We go to assignment 4. I copied here. This whole thing. Just so we have all the controls. Yeah, there you go. Now we can actually go look it from different angles. Of course, it's just like all the triangles are red, so we can't see the difference. Maybe you can. What you should do to debug is instead of color here, maybe you can put some kind of hard-coded different colors. Maybe red, like red for some of them. Blue here. Oh, actually, yeah, let's keep like red, and then the ones at the bottom, we make them blue. Or oh, cool. Yeah, it looks perfect. That's how I was. That's what I was expecting. So we got exactly this rendering here, right? As I mentioned, the triangles here on the poles, they are much smaller, and then as you get closer to the equator line, then they're a little bit larger, and then they get smaller again. Okay. Cool. Perfect. No bugs. Actually looks really cool. What we can do is maybe play with the size and see what happens. Maybe like, let's put 10. See, now we have like less resolution. Or the sphere is kind of like starts more like look like a polygon. And if you increase this number, you're gonna look more perfectly, it's gonna look more like a sphere, but also cost more vertices. Actually, it's taking a long time to generate. 100 is too much. Yeah, let's make it 40. Yeah, no, 100 is too much. Wow. Also, this print here might be it's probably taking a long time. Yeah, see, so it kind of gets more accurate and looks actually more like a sphere because you have more resolution. But I think 20 or even 10 maybe is a good number. Yeah, maybe 10 is a good number. Or not 10, no, 20 is a good number. 20 like, yeah, 20 is perfect. Kind of generates fast and looks good. Great, I'm gonna go back to like change the color here. So you can have any color you want. And that's it, that's the code for this here. Oops. Oh, I see the problem. Okay. Great. Any questions?